The basic idea is to relate thin concentric rings of the circle with horizontal slices of the triangle, because the circumference of each such ring is increasing linearly in proportion of the radius. To prove it mathematically, we have to do integration. So, integral of 2 pi r times r sine theta d theta from 0 to pi. Taking out 2 pi r squared as constant, then integral of sine theta d theta from 0 to pi equals to 2 pi r squared times integral of sine, which is negative cosine theta, from 0 to pi. So it would be 2 pi r squared times negative cosine pi minus 2 pi r squared times cosine 0. Canceling out cosine 0 and negative cosine pi into 1 equals 2 pi r squared plus 2 pi r squared equals 4 pi r squared. Geometrically speaking, a sphere is composed of small vertical rectangle that is an infinite number. When you project that rectangle and rotate it in a horizontal manner, you can create a cylinder that has no top and bottom cover, and its height is equal to the diameter of a sphere. When you cut the cylinder, you can create a rectangle with a length that is equal to the circumference of the cylinder. Then the width is equal to the height of the cylinder. Therefore, the surface area of a cylinder with radius r is equal to the surface area of a sphere with radius r. We need to unwrap the circles into a triangle. With this, the width of the triangle is equal to the radius, and the length is equal to 2 pi r. If we will compute it, the area of the circle, which is pi r squared, is equal to the area of the triangle, which is 1/2 times 2 pi r, which is the base of the triangle, times r, the height, canceling out 2, equals to pi r squared. Therefore, the area of the circle is equal to the area of the triangle. In connection to this, the rectangle cut from the cylinder has the same area of 4 pi r squared, with height that is the diameter and length that is the circumference of the cylinder, 2 pi r. To get the area of the rectangle, we have to multiply the length with its width. So it will be 2r, which is the width, and times 2 pi r, which is the length, equals to 4 pi r squared. If we will try to cover it with the same triangles unwrapped earlier from the circles, having an area of pi r squared each, the total surface area of the 4 combined triangles will still then be equals to 4 pi r squared. After all of these, we can say that it takes 4 circles with radius r to cover the surface area of a sphere with radius r. And that would be all. Thank you for watching.